Find the area of a parallelogram bounded by the y-axis, the line at x equals 3, the line at f of x is equal to 1 plus 2x, and the line parallel to f of x passing through 2 comma 7. Great. So first let's graph it, right? Let's draw it out. So just create a simple axis, right? Now let me make that pen a little thicker. How about this one? There we go. So let's draw an x and a y-axis. And maybe I'll bring this, I can already tell, I think we're going to be up a little high on the y-axis. So we'll bring that x-axis down. So here's the x and here's the y. And let's start plotting the lines. All right, so it wants to find the area of the parallelogram. And the parallelogram here is bounded by, meaning it's going to be contained within the y-axis. All right, so I already drew that y-axis, right? I'll put it in red. Let me just change the color. So there it is. Next thing it says is the line at x is equal to 3. So let's make that line, right? So if you go down to your x-axis here, right, that's x of 0, x of 1, x of 2, and then here's x of 3. So the line there, will be straight on down like this. Okay, so that represents now x is equal to 3. Because everywhere along that line, x is 3, right? What's the x-coordinate here? 3. What's the x-coordinate here? 3, 3, see? Next line. F of x is equal to 1 plus 2x. Now, you have to recognize that that is the equation for a linear line. It might look a little strange. You might look and say, well, I'm used to seeing it y is equal to mx plus b. That's always how I've learned it. And now, that doesn't look like it. Well, remember that addition, it doesn't matter the order. How you add things, right? 1 plus 2x is the same as 2x plus 1. So we can simply rewrite that, and now it looks a little more familiar, right? Here it is. So the slope is 2, right? And the y-intercept is positive 1. So first start with that y-intercept value. So what that means is this equation of a line will intersect the y-axis at a value of 1. So here it is. There's the value of 1 on the y-axis. Now, the slope. They told us that it's 2, right? Now remember, slope is always going to be change in y over the change in x. So whenever you have this value 2, turn it into a simple fraction. Don't get scared. Fractions are not that scary. Right? 2 over 1. Okay, is the same as 2. Now this tells you then how much y is going to change and then how much x is going to change. So let's go back to the graph. So what you do is you start at your point, and now you're going to go up 2 units. Why? Because y now, letter y, changed by 2 positive 2 units. So you go up 2, and then it says x changed by positive 1 unit, so therefore you're going to go over 1. And here's your now new point. Okay? So let's just erase all that, and I'm going to plot it right there. And we would continue this. Go up 2 over 1. There it is, right up 2 over 1, blah, blah, blah. Okay? And now we're going to draw it. We'll try to sketch that on out. That looks pretty good. Okay. Next but not least, last but not least, not next, but okay, yeah, is now we're going to do a line parallel to f of x, passing through the point 2 comma 7. So basically, the line we just graphed was our f of x. And now we have to create a line that's parallel, okay? And it has to pass through the point 2 comma 7. So first, start off with this particular point. Find that point, 2 comma 7. So we go over 2, and then we're going to go up 7 units, right? So 1, 2, 3, 4, 5, 6, 7. So right here, okay? I'm going to erase all that, and I'm going to plot it there. And now I have to create a line that's parallel to f of x. So it's going to have the same slope, right? So you can go up 2, over to the right 1. You could also go down 2 and over to the left 1 as well. See? And I could keep going, right? We can keep going. And now here is this new line. Let me try to make that a little neater. Okay, that's good enough. So now what they want us to do is they want us to find now the area of the parallelogram that is bounded by these 4 lines. So what I'm going to do is I'm going to try to highlight it. Okay, so I'm going to highlight it. Here it is. It's a little hard to see, but I think it'll make sense now once I highlight it. Right, this is the region that is now bound by those four graphs, right, or contained within those four lines. Okay. So notice how that area is contained within f of x, then the new one that we had parallel to f of x, then we had the x is equal to 3, and then the y-axis. Okay? We got to now find the area of that. Now this part is the easy part, I believe. Okay, the area of a parallelogram, and we want to memorize this. The area of a parallelogram is going to be simply the base multiplied by the height. Very, very simple. Okay? And remember, for a parallelogram here, I'll draw a simple little model. Okay, here is our parallelogram. The base is defined as one of the sides. It really doesn't matter which one, but I'm going to call this one, the bottom one, the base, the whole length. Okay, the whole length here is the base. And then the height of the parallelogram, and you can also kind of consider the top also being a base. All right, I know it's like, well, base, doesn't that kind of mean bottom? Yeah, it kind of does, but the way I'm going to explain the height is going to be easier if I call them kind of both the base. Okay? And the height then is literally simply the length between the two bases. Okay? Or between just simply two sides of your parallelogram. You could write it there, you could write it here, you could write it there. Does not matter. Okay? And that's the height. So that's what you got to know. You got to know the base and you got to know the height. So now let's just simply look at our picture. And let's see if we can figure out the height. Or the base. It doesn't really matter. Right? So which one should we do? Which one might be easier to do here? Well, the height might be easier to kind of grasp first. Right? So what would the height be on this? What do you think? Or the base, it doesn't really matter. If you notice also one other thing, if you go back to the picture, these two have to be at a 90-degree angle to one another. So that's really what's important. It doesn't matter what you call the base and what you call the height. You could have easily called these two sides also the bases. And then if those were the bases, then the height would have been this way. Okay? Does not matter. So in keeping consistent with my model on the right, the base here is going to be, it looks a little strange, but the base here is going to be a horizontal length, right? Kind of like this, one of these lines that I'm drawing. Okay? Now, what do you think that distance is there? What do you think from the plotted dots? It looks like a value of 1 to me, doesn't it? Now that correlates with the horizontal base there. Okay, you could have easily called this also the base, the vertical length. But I'm trying to be consistent here. I'm going to call the vertical length the height. All right, it doesn't really matter. So the base here we'll call a value of 1. Okay, the base has a value of 1. So let's write that in, 1. And then we're going to multiply it now by the height. And the height I'm taking to be the vertical now. This distance, or this distance up here. So what does that look like to you? It looks like it has a value of 2, right? And that's it. That's how easy that is. What's 1 times 2? Obviously it's 2. So the area of the parallelogram bounded by these 4 lines is 2. Thanks guys so much for tuning in. Appreciate it. Please remember to help us out and subscribe. Hit that like button and tell your friends. We'll see you soon.